Hey guys, and welcome back to a new video and a new playlist about the brand new Navigation3 library on Android and Compose multi-platform. This will be a completely new playlist in which I will create modular videos about every single important feature of Navigation3. In this first video, we will create our very first navigation setup here after all, with a typical list and detail screen here in a Compose multi-platform project. But in case you are a native Android developer and you want to learn using Navigation3 for native Android, please also use this playlist because I will intentionally build and record it in a way that it will work for both Compose multi-platform as well as native Android. Since in the end, native Android is kind of a subset of Compose multi-platform and one of the platforms we support with it, the setup is almost identical. Really, 95% of the code will be the same for native Android than for Compose multi-platform. And for those remaining 5% where there are some differences necessary, I will simply say so in these videos. So what we're going to build here is a simple list detail screen navigation. Left side here is Android, right side is iOS. We have a list of some sample to-dos. They're just hard-coded and don't come from a DB here, since the focus is on navigation. But if we click on a to-do, then we get to our to-do detail screen and we can then navigate back. And the same thing, of course, here on Android works the same way. And then there will, of course, be follow-up videos where each one dives deeper into Navigation3. We will talk about nesting nav graphs, about deep linking, about backstack management, about all these cool things that the new library allows us to do. And before we dive into a new project, what actually is Navigation3? That is a new navigation library here from Google, specifically for Jetpack Compose and Compose multi-platform. While there was an existing navigation approach in Jetpack Compose, specifically Compose navigation, that approach still exists, that approach is not deprecated, you can still use that. If you are already using that in a project, that's perfectly fine and you will still be able to keep on using it. However, Navigation3 is a library that is designed mainly to fix the most prominent issues that we had with the previous approach of navigation, mainly backstack management. So on Android, we have the backstacks, in the end just a stack or a list of all the previously visited screens. And with the previous approach of Jetpack Compose navigation, we as developers did not really own the backstack. So we could push new elements on top of this backstack by navigating somewhere. We could pop certain elements by just removing the topmost entry of the topmost screen. But we did not really own the data structure of this actual list, which we do with the Navigation3 library. So we really work with our very own backstack in our code. We could technically shuffle it, we could reverse it, but we can of course also just add new entries and remove existing ones, which gives us much more control over how navigation works in our app. So let's dive right into it. This is, as I've mentioned, a Compose multi-platform project, the very initial empty one. As I mentioned, you can also create a new native Android project and you will be able to follow along. In that case, new, like file, new project, and then here either an empty activity for a native Android project or scrolling down to the Kotlin multi-platform template here in case you also want to support iOS and desktop. For native Android at this point, Navigation3 is stable. For Compose multi-platform at this point, it's in alpha for iOS and desktop, but also stable for the Android side. And depending on when you watch this, it may already be stable for Compose multi-platform as well. So once you've created this project, we first of all need to set up the dependencies, so our library references, in order to use Navigation3 in this project. This is something we can do in our version catalog here in our Gradle folder. Simply double click on libs versions. And here we come to all of our version references. Let's maybe first of all make sure that we update all these yellow highlighted ones to the latest corresponding references here. Not that we need all of those, but I don't like warnings. So let's hit Alt Enter on all of these and update these to the latest versions. But additionally, I will also paste a few more versions here and dependencies, specifically for Nav3. For all these things that I copy-paste here in this video, you will of course find links to the corresponding GitHub repository down below, so you can also copy-paste this stuff that isn't that nice to type off. Specifically, we have a Navigation3 version in case you're using native Android, as I've mentioned, stable version, and we have a version here for Compose multi-platform specifically, which at this point is in alpha. Of course, if you add this and it also shows this yellow warning for you, you are more than welcome to update that library. Furthermore, we need to add some library references here, so at the very bottom, let's paste these dependencies again. Using Compose multi-platform, you only need these two. And if you're using native Android, you only need these two. Specifically, we have Navigation3 UI, so the actual UI composable references that we will use here in these videos. Lifecycle view model Nav3, this will give us the option to actually also scope view models to a specific screen in Navigation3. And here in Android, we have similar dependencies. What's very important, and that's the same as with the old approach of using compose navigation, we are using Kotlin X serialization as our primary way to serialize our navigation destination. So you must think about this like this, that every single screen the user could possibly visit in your app, we will represent that either as a data object in Kotlin or a data class. A data object if we don't need any arguments to visit that screen, but if we do need to pass certain arguments, for example, here in our to-do detailed screen, we need to know which to-do we've clicked on to show this to-do here. Then we will work with a data class that has an argument, in this case, a string that reflects the to-do text that we've clicked on. And these will be our destinations, so simple classes. But in order to really also persist this backstack, especially on Android, to make it survive screen rotations and configuration changes, it needs to be persisted, which happens mostly under the hood, but needs Kotlin X serialization in order to serialize these classes for the destinations that we will create here. When then using Kotlin X serialization, we also need to add the Gradle plugin here under plugins. So this is the last part for our version catalog, Kotlin serialization. And now we can actually reference all these different new names and libraries here in our corresponding Gradle files. First of all, we want to go to our very root level Gradle file and reference our Gradle plugin there. So here, build at Gradle at the root level, we could duplicate the last line, the last alias here, and simply reference Kotlin.serialization. This won't be recognized here because we haven't yet synced the product, but since I would like to get through this with a single sync, let's first of all add these remaining references here, also in this build.gradle file inside the compose app module. So let's double click on that one. And here we have our different source sets. So in compose multi-platform or Kotlin multi-platform rather, we have this common main source set, which will include all the shared code for all the platforms. And since navigation is definitely something that we want to share between platforms, this common main dependencies block here is also where we want to reference our different dependencies. So let's have an implementation line where on the one hand, we want to reference this JetBrains Navigation3 UI dependency. We just need to substitute this on the one hand with libs.jetbrains.ui like this. So we just replace the dashes with periods. That would be one dependency. Let's duplicate this with Command D. The other one would be JetBrains Lifecycle ViewModel nav3. JetBrains Lifecycle ViewModel.nav3. And the Kotlin serialization one. So let's duplicate this once more. Command D for Kotlin X serialization. JSON Kotlin X serialization.json. So much about the actual library references inside common main. Now we only need to also add the serialization plugin here to our plugins block. So this is really also applied for this compose app module we're in here. So let's also duplicate the last line here, whatever that is for you. And we say libs plugins Kotlin.serialization. That should be it, just like here. Cool. Now I would say we now synchronize this and then hope for the best. That Gradle doesn't have other plans for us. But if everything is successful here, we can then take a look at our actual Kotlin files as a next step. All right, for me, that sync was successful. Hopefully the same is the case for you. Let's dive into real coding and jump into Compose app common main, because this is, I think, actually the only place in this video at least where we will have to write some code. And that same code will apply to Android almost identically. The first thing I want to do is actually something that works the same way with the old approach of navigation, I think it's Navigation3 or Compose navigation, of us defining some routes. So I want to create a new package inside this nav3 guide being called routes. And in this routes package, we can, well, let's actually call this navigation for all the navigation specific features. So I've renamed this here with Shift and F6. And then we can create a new class or new file in there, which we will call route. So this will be the superclass, the parent class of all of our different screens that we want to be able to visit in this app. This will be a sealed interface. So let's make this an interface and then simply add the sealed keyword over here. And this is now actually the place where we want to define which screens we have in our project, in our app, and what kinds of screen parameters or arguments these actually take in order to display these or visit these. In our simple example, this is on the one hand a data object for our to-do list, and that is a data class because for the second screen, our to-do detail screen, as I've mentioned, we will need an argument. We will need to pass our to-do item, the actual to-do string here, that we've clicked on, so the second screen that we visit also knows what it should display there. So this will be the to-do detail route. And here we will pass the actual to-do in form of a string. Since, as I've mentioned, all of these entries that will now in the end make our whole backstack, now a whole backstack in this case, will really be nothing else than a mutable state list managed by compose. So just a list in the end where every single entry is a compose state and could be one of these routes here inside of this route serial interface. And because that needs to be serializable, as I've mentioned, we need to annotate all these things here with serializable and then Alt-Enter. That's not importable. What is the problem here? Can we do this here? Serializable. Now it appears. Okay. The moment this underline appears, you can hit Alt-Enter to import that and then also apply serializable here and here to just make everything here serializable. However, this is how it would have worked with the older navigation approach. But with the new navigation approach, our backstack actually consists of so-called nav keys. And a nav key is really nothing else than a specific destination of our app, a specific screen. And in order to be able to use these different routes here for our backstack, we need to also mark these with the nav key interface here coming from Navigation3. So simply make sure you implement this interface for all these different options. That won't require us to actually implement any members of this interface, but just marking these as real routes that we can use in our backstack. Same thing, we should also inherit or rather implement this route interface to indicate that these are all of our valid routes. But that is then already our definition for what a route is and which routes we can actually visit in our app. Let's next actually define our different screens, so the actual composables that we want these destinations to lead to. I will put this in a separate screens folder here, screens, and a new file in here with to-do list, making that a file, and using comp in here to just create a simple composable that will display a list of to-dos in this case, to-do list screen. And of course, this will be a simple example here that mainly focuses on teaching navigation, but in a real production project, there are of course more best practices that you could apply here to really make this a scalable approach. Just as a little disclaimer, if that's something you want to get better at and you would like us to help you with that, then feel free to take a look in the description, because we really have a mentorship program in which we help you very, very closely with your Android and Kotlin multi-platform skills. So inside this to-do list screen, we will really just have a lazy column, so some to-do items, where we can pass in the modifier we got here from this composable. Modifier is modifier. We can pass some content padding so this doesn't look too cramped, of 16 dp, I would say. And other than that, we can work with an items block. Not specifically an items block here, because I would actually like to also create a view model reference in the screen that we also couple to the lifetime of the screen, since this is how things would just typically work like in the real world. You will have a view model that contains the screen's logic, and that you will bind to the actual lifetime of the screen. So for how long it is on the backstack until the user dismisses it by navigating back, for example. So let's put this view model here in a separate package called ViewModels, and we maybe call this to-do list view model. This should be a class now, and it should inherit from ViewModel. And it does not need any real constructor parameters here, because we really just want to have a list of to-dos, for example. We can make this a private state and then expose a public immutable version. And we say mutable state flow off, where we say, okay, we have an empty list initially, and this will be a list of strings, where each string is in the end just the to-do text that we can see here in the app when navigating back. So all these different texts, we will have 100 of those that we display in the UI. Actually, we don't even need to start with an empty list, because we already know these 100 entries. So we could just go inside here and say we have a range from the numbers from 1 to 100, and we map those to to-do texts. So to-do with a current number that we're iterating over. So simply a list with 100 elements. We will then also have a to-do's state flow that is immutable. So we convert this one to an immutable one with as state flow. And this will really be our simple view model here for this screen at least, that won't do anything else and won't have any real behavior. Cool. Inside our to-do list screen, we can now have a view model reference from which we get this list of to-dos that we now want to reference here on the screen and show in our lazy column. This works like this. We have a view model reference of type to-do list view model. And now there are, of course, multiple different ways how you could get that view model reference. Here I will just use the normal compose view model function that will give us a normal reference of this specific view model. However, of course, if you're using a specific DI library like Coin or Dagger Hilt, Dagger Hilt not in a Compose multi-platform project, but in an Android project, that would be valid. In that case, this could also just as well be substituted with Coin ViewModel or Hilt ViewModel. Since our ViewModel does not really have a constructor, we can create it directly like that. We don't need to provide any specific parameters or arguments to this constructor, so we can really just leave it as it is and simply observe our to-dos state. So we can say val to-dos by ViewModel dot to-dos, and we collect this as a state with lifecycle, this one here. Go in here, Alt Enter to import this get value delegate, and now we can observe this to-dos list inside the screen, and therefore have an items block in this lazy column that also takes in a list of something, specifically our to-dos. And then for every single to-do text, we can just show a text composable, where the text is just whatever that to-do is. Here I would also like to style this text a little bit, so it's not too cramped, by giving it a modifier that is equal to modifier fill max width first of all. We then give it some padding of 16 dp. And here before applying this padding, so to really make it span the whole size of this text, we want to make it clickable because of course the moment we click on this text, we want to perform a navigation transition to the next screen. So we need to execute some kind of lambda in order to bubble up this event for this navigation transition to the parent composable, which will then manage our navigation. So let's put this lambda in here on to-do click. And this lambda will take a parameter of type string, so specifically the to-do that we've clicked on, and that won't return anything, so simply unit. We can then take this on to-do click lambda, and we call this here in the clickable modifier, and the parameter we pass is simply the current to-do we're iterating over. The same we can now do for our to-do detail screen, which is even a little bit easier, at least in regards to the UI that we want to show there. Let's first of all start with the view model, and for that we can copy-paste our to-do list view model and name that to-do detail view model. In here, well, we are not going to work with a list of to-dos, but rather, actually no real state at all. We could create a little state class here just that you would see how that could work. We could have a data class to-do detail state in which we keep our state here. And in this case, it would simply be the to-do that isn't even really dynamic in this case. So I wouldn't make this state at all, but just that you have somewhat of an example of how this could work by going in here and saying, okay, we have a to-do detail state, which is held by this mutable state flow that we also call underscore state here and here. And this one would be called state like that. Now, of course, this to-do string must come from somewhere. And specifically, it comes from our navigation transition from our to-do list screen to our to-do detail screen. In this case, for navigation arguments with Navigation3, it works simply by passing this to the view model as a constructor argument. So simply a private val to-do for the to-do text. And then we can take this constructor argument we initialize the view model with, and we pass that here to our to-do detail state class. Now let's also quickly copy paste our to-do list screen and make that a to-do detail screen. And we also need to rename the composable here to to-do detail screen. And the view model must be a to-do detail view model now. We don't get a lambda here because on the to-do detail screen, we have already clicked on a specific to-do, so we can safely remove that. But from our view model, we now actually get the actual to-do we've clicked on. Optionally, we could also pass that, no, actually not optionally, but we have to pass that to-do as a normal argument here to the composable as well. And then we have the choice to either listen to that directly via this nav parameter. That is what I would prefer here because this is in fact a static argument. Once having clicked on a specific to-do and once being on that screen, for that lifetime of the screen, this to-do string will never change. And therefore, I would not really consider it as part of the state because the definition of state is simply a value that can change over time. And if a value can change over time, like this to-do string here, at least for the lifetime of a screen, then don't make it as part of your state. So what we can do is we can go inside this code. Let's completely get rid of this here. And rather put in our string or simple to-do text here in a box. We say, we give this our modifier, fill the whole size of our screen, and we just center whatever is inside that box with a content alignment argument, where we can say alignment.center. And inside this box, we can then really just put our text with our to-do here. Maybe we could also give this box a little background, in case you want that, with a background modifier, and maybe material theme, that color scheme. And we take our secondary container color maybe. Now, navigating to the screen as we have it right now would not work because our to-do detail view model actually takes a constructor argument. And the moment a ViewModel takes a constructor argument, we need to provide a so-called ViewModel factory that defines how such a ViewModel instance is created. Now, when using a DR library like Hilt or Coin, that is handled for you, but also with normal navigation arguments, you would have to pass these on your own because you would not define these in your DI modules in this case. Coin actually already has an extension for Navigation3, but it's not yet really advanced when recording this video. So I may add another video here in future when that is more advanced, because Coin actually, the makers of Coin work on a quite alternative approach of defining your navigation history or your navigation setup. But right now I would not recommend this because it's more of a hassle, it seems. Anyways, we need to somehow pass this to-do here to the to-do detail view model, and we're not using any specific DI library like Coin or Hilt. The easiest way to do this is to simply take this view model composable function, open a block of code here, and simply define how such a view model instance is created by saying, okay, to-do detail view model, and we pass the to-do that we've passed here to this composable function as a parameter. And then this will be the way how the view model will be initialized here for this particular screen. On this screen here, in this simple example, the view model is not even needed. You can see it's grayed out. But of course, it's interesting for you to know how you would also get these navigation arguments in the view model itself. Because, for example, if your to-do would come from a database, you would save that in a database, then the recommended way would actually to not pass the whole to-do information, which would possibly include more pieces of data, like whether it's done, description, title, author, I don't know, but rather just passing the idea of that to-do and then loading the information for this to-do from your DB in this to-do detail view model. That is the preferred approach. Always keep your navigation arguments as light as possible. They are not made to carry large amounts of data. So now we have our two different screen definitions in order to navigate between these. And that's of course what's missing now. We want to implement the logic how navigation works between these screens. And that's now where Navigation3 really comes into play. So let's go in our navigation package and we'll create a new file called navigation root. That is a name that I like to choose for the very root composable that includes our navigation setup. Make this a file, composable, navigation root, and in here, the composable that we want to work with Navigation3 is called a NavDisplay. If you come from a Navigation2 and composed navigation, then this is kind of the equivalent to what a nav graph has been. So it's in the end a composable in which we outline which different screens we have in our project and how these look like. So which composables we really want to show and render on the screen when visiting a specific route that we've defined in our route sealed interface. So let's have this nav display and take a look at all these overloads that we get here, because we get a lot of overloads. And while we're not going to take a closer look at all of these here, because that is why I will have separate videos about Navigation3, the most important one will be the very first property, and that is our backstack, because that is the main difference between Navigation3 and the previous approach. In Navigation3, the backstack is simply a list of something. And if we have a list of something, then we have the full control over how our backstack looks like and how we want to change our backstack. And in Navigation3, we can get an instance of such a backstack, of such a list of, in the end, nav keys, by saying val backstack is equal to remember nav backstack. That is the core composable here, composable function, that will give us a nav backstack of type nav key. And if we actually hover over that and then click on what a nav backstack really is, we can also find that out in a bit more detail. It's in the end a custom class, but under the hood you can see it's nothing else than a mutable list of some sort of object. So all the functions, all the fields that we can access from a mutable list, we can also use in order to change and mutate our backstack, which is super, super cool. It's also important to mention that this remember backstack function will automatically persist your backstack, because on Android we have the problem of configuration changes when we rotate our device, when we switch the device theme and so on. Then the underlying activity, so the container for our UI, will be recreated, and normally without further care, everything in our UI would be reinitialized, including our backstack, which would then be reset to the very initial list that in the end just contains our start destination. Not what we want. We want to in the end stay on our screen the moment we rotate the device. So it's recommended to use this remember nav backstack function rather than constructing this list on your own somehow, unless you explicitly implement logic to restore it. But that would also be a bit too much for this video, so let's start with the remember nav backstack function. Because that in fact takes two arguments, on Android this function will only take one argument, specifically these elements here of type nav key. Little reminder, nav keys are nothing else than each route that we've defined here. And here we in the end just need to define the initial state for our backstack, so the start destination after all. In Kotlin multi-platform, we additionally need to provide this configuration in form of a saved state configuration, which is in the end nothing else than kind of a config that outlines all the different routes that we could visit and how they should be serialized for this serializable backstack we get here. The reason this is not needed for the native Android side, but for Kotlin multi-platform is that on the native Android side, we actually use Kotlin JVM. That's also the reason why on native Android we can use Java references in our Kotlin code, while in a Kotlin multi-platform project we can't. And the Kotlin JVM version is just a bit more flexible with reflection, so getting certain class references here in our code, which is why on Android we actually don't need to provide this context, since the Navigation3 library can infer it on its own, while in Kotlin multi-platform we don't have this flexibility, so it wants us to actually provide which routes we can possibly visit here with this backstack. This is luckily pretty easy, even though it's a little bit of boilerplate code here. We can simply define this with a so-called saved state configuration, which is nothing else than a block of code that will open here. And inside here, we can then define the so-called serializers module, which will define how certain types of routes should be serialized in this backstack. This can then be set to a serializers module, which is again such a block of code. And in here we can then define how our Kotlin X serializer should work with our routes. Specifically, we want to define polymorphic, which in the end sets up a polymorphic serializer. So polymorphic in the end means a kind of inheritance and an inheritance class hierarchy. Since we want to say we have a certain parent type, which are our nav keys. So we say for nav key : class, we have certain child types that we want to be able to serialize from this parent type. And here we can then say, okay, we give this a certain subclass, which we now have to call for every single route we have in our route KT interface, like saying route.toDoList : class, and as a second argument we pass the serializer, which is automatically generated by the Kotlin X serialization Gradle plugin, so we can reference this via route.toDoList.serializer. And that will then work for serializing the to-do list class that we have here. We can then copy paste this or duplicate this, Command D again, do the same for to-do detail and to-do detail serializer, and this is the setup we need here for the very initial backstack in order to make our KMP project also properly serialize it. Additionally, as the second argument here for this remember nav backstack function, we want to provide the very first start destination, so the very first screen the user visits when they open the app. And this is something we can just put in here as a simple route. So we say route to-do list should be the very initial screen to visit. And now we have a proper backstack instance that we can pass to our NavDisplay. So here we can say the backstack is our backstack. And the second very important piece of the NavDisplay is the so-called entry provider. You can see that is nothing else than a lambda that gives us an instance of t. T is in the end the type of nav key we work with here, in our case just nav key, so specifically the destination we're on, and we then need to map this to a so-called nav entry. Nav entry is nothing else than a wrapper composable, or a wrapper around a composable rather, that will then serve as a specific screen in our app. So let's use this function, open this here. As I've mentioned, it will give us the nav key instance. Hovering over that, you can see this is in the end just a parameter of type nav key. So under the hood, this nav key could now either be a to-do list, which is a nav key, or a to-do detail, which could also be a nav key. And that is now what we need to check here. We can do so with a simple when expression by checking whatever that key is. If that key is a route.toDoList entry, then we can have a nav entry. Remember, this is what this lambda here needs to return. So we say we have a nav entry, import that, which takes the specific nav key to display here as a parameter. So we pass in this key and then open a block of code, which is not really composable code. So here we can now call the specific composable we want to show when visiting the to-do list screen. And that, well, is our to-do list screen composable. Does that take any arguments? Yes, it does. This onToDo click lambda, which we can provide here, onToDo click, and this would now be the place for us to perform our navigation. Let's put a to-do here for now, navigate to to-do detail, and get back to that once we've defined this entry provider lambda. Because we obviously now need to have such a when branch for every single different route we could visit in this context. So let's duplicate this code. Have the same branch here just for the to-do detail screen, and simply substitute this to-do list screen here with our to-do detail screen. And this now actually takes in the to-do that we've clicked on. How do we get that? Well, since we've passed this to our to-do detail route, we can simply get it from this route. So from our nav key that we got as an instance here in this entry provider. And since Kotlin has a smart casting feature, that means if this when branch enters, Kotlin knows that in this scope of code here, this key must be of type to-do-detail, so we can directly access the specific properties that only exist for to-do-detail routes. And that is our to-do here. You can notice, even though that we've defined both of these nav entries here for both of our routes now, we still get an error because every single code path here needs to return a specific nav entry. And since even though we have a sealed interface, there could still be possibly different nav keys that we've defined elsewhere in our code. So we in the end just need an else case of this when expression in which we would say, okay, if we pass some sort of nav key and try to navigate to that does not exist in these when branches we've defined so far, well then that is obviously an error in our code because we did not add this route explicitly. So we could say error unknown nav key, and then we pass whatever key we tried to pass there. So this will crash our program so that we know, okay, we probably forgot to add a route here to our when block. So this is really the initial setup for our NavDisplay composable. We just defined the backstack. As I've mentioned, this is really nothing else than a state list in Compose. So every single entry of this backstack, again, nothing else than a list here under the hood, is a compose state, and therefore the NavDisplay composable will observe this backstack, and whenever that changes, whenever we add a new entry to this backstack list, whenever we remove an entry, whenever we change the order of these entries, then our NavDisplay composable here will recompose and possibly give the entry provider a call here with a new key that then reflects, or that then in the end maps each key to a specific composable that should be shown the moment the currently visited screen in our backstack is whatever this key here is. So this means if we now want to navigate, all we need to do is we need to take this backstack instance and we need to add a new nav key here. So we can say that nav key should now be our to-do detail key from the route interface, and we pass in the to-do that we've clicked on, which we get from the lambda function here. So we can simply pass it. And that's almost it yet. Let's, by the way, call this navigation root composable here in our entry point of the app in the app.kt file. Here, this is the composable that gets shown when we really launch the app. In a native Android project, you would simply put the navigation root composable call now in your activities set content function. So here, simply navigation root in here, but in a Compose multi-platform project, we typically have this app composable. So let's put it in here, inside the material theme, of course, by saying, let's actually put this in a scaffold to handle window insets. We get our inner padding here, and then we could say navigation root, and the modifier is modifier.padding with our inner padding. Now, let's actually run this. Let's give this a try. We run this here for now on our Android device. And I actually get a dependency issue. Did I accidentally reference the wrong version? This definitely doesn't look right here. Let me quickly try to take a look in libs versions. TOML. Here we reference Android X lifecycle, and that version is 2.9.6, which is not the one I want to use. So let me just copy paste all the exact version references here for this upper block that I have in my prepared project, which is like this. And here this Android X lifecycle is this 2.10 alpha 05, which is an alpha version that now also exists here for this particular dependency. So it's a more recent version after all. After having fixed that, we can also sync this again. And we have an invalid TOML definition. So somewhere we reference Kotlin coroutines for swing. Yeah, let's remove that. That is for desktop if you want to use coroutines there. And compose hot reload is also something I've removed. So we can remove this here. And we can also remove this in our Gradle files, since that in fact has been merged recently with the Compose multi-platform Gradle plugin. So wherever you have a reference to compose hot reload, you can also remove this reference. And here we can remove this coroutines swing for desktop for now. Try again. And after that sync was successful, let's give this another shot and run the project on our Android device over here. All right, it launches. And if we now click on the to-do 27, then we get to our to-do detail screen 27. Let's now see if we have a screen rotation. That also works. Rotating back, and we navigate back. Then we also get back here to our initial screen. Let's also add something, by the way, in our to-do detail view model here. So you can actually see how the scoping of these view models works by default. We have a print line here when the view model is simply created and initialized by saying to do detail view model initialized for whatever to do that is. And we do the same in on-cleared, so when the view model is destroyed, oops, I just want to add this once, view model cleared for to do. Let's run this once more. While taking a look here in logcat and searching for to do detail, clicking on to do 7 will initialize the view model here for to do 7. Going back does not really clear it, as you can see. So even though on the surface everything looks as expected, this is not what we would expect, because normally, especially in the previous approach of compose navigation, going back would mean the corresponding view model that is scoped to that particular screen, in this case the to do detail screen here, would just be destroyed. And in this case, it's not destroyed. So when going back, we don't get the line that the view model has been cleared here. And when going to another to do, then we also don't really get this initialized for to do 12 here. Why is that? Well, because there are some, let's call it some magic that needs to be going on here behind the scenes in order to really scope a view model to a specific nav entry. And in order to allow and enable this magic, Navigation3 works with so-called decorators. So decorators in the end a design pattern in software that allows us to add certain behavior to something, so to our NavDisplay, for example. And we can simply do this by going to our navigation root, and we of course also want to use this modifier here, just noticed, reference the modifier, but then there's also an additional argument for the so-called decorators, entry decorators, this one here it is, which is a list of nav entry decorators. And there are just some predefined of these decorators we can add here that on the one hand will probably make sure that the backstack is persisted properly and that view models will also be properly scoped. This is on the one hand, remember savable state holder nav entry decorator, very long word. And on the other hand, remember view model store nav entry decorator. So this one is, for example, the one that will make sure that view models will be scoped properly. And we simply need to add these decorators here to the nav display in order to enable this behavior. Here, inside this decorator, we optionally have the option to say, remove view model store on pop, where we can pass a boolean whether we want to actually destroy a view model when a specific screen it's bound to is popped from the backstack. So that's not the default behavior, and this would in fact make the view model a global one that will just be initialized once and then live forever, just like the example we've seen. The default is simply true, so we don't need to provide this lambda. We can also just call it like that. And then let's try this once more. Take a look in here, take a look in logcat, and now click on to do 9. Then the to do view model was initialized for to do 9. If we now go back, then you can see now that view model was also cleared for to do 9. And now going into another to do will then also properly give it its own view model here, in this case for 13. Going back will then again clear this to do 13. So this is now exactly the behavior that we would expect when scoping a view model to a specific screen. And of course, if you want, you could also run this on iOS without any changes. Of course, only if this is a Compose multi-platform project, by going to Compose app, iOS app, and then simply running this after having selected sort of a simulator like iPhone 16 Plus, for example. Let's give this a shot. Sometimes takes a little moment until the iOS side is built. And there we go, our app is installed, it's opening, and it's crashing. Interesting. What is that? Here we get a big issue, factory create unsupported operation exception. Okay, I've looked into that issue, and that was actually new to me, but it only relates to the view model function that we use here, the view model composable, using coin, so the coin view model function here, with that it works for iOS out of the box. But apparently, when using the normal view model function here, this initializer block only works for Android if we don't add this extra dependency for JetBrains lifecycle view model. So ideally, since this will be contained in the GitHub repo, you already have this here, since I will include it, of course. But in the end, just reference the same Android X lifecycle version, just like the view model nav3 dependency already. And something important to also mention is that every such view model call really needs this initializer, even if the view model does not take any constructor arguments. So now running this again here on the iOS side, of course doing the same here for our to do detail screen, or is that here? So here we also have this initializer, but that is what we already had before. Just important that you also add it to the to-do list here. Taking a look at the simulator, you can now see it also launches on iOS, and clicking on a to-do will also give us the to-do. And I think here it should also print, view model initialized for to-do 8. Navigating back will give us cleared for to-do 8. Very nice. So in case you want to get ready for the industry with Navigation 3 and use that in bigger projects, in production scale projects, and you want us to help you get there as fast as possible, then apply to the mentorship program. Link is below. We're really in exchange there on a daily basis to work on your specific technical struggles. Thanks so much for watching. I will see you back in the next video. Have an amazing rest of your week. Bye-bye.